Hello, this is Priyanka. This is Priyanka Katare, Assistant Professor in Department of Electronics Engineering, Walchand Institute of Technology, Solapur. Today in this presentation, we are going to see one of the important algorithm in the artificial intelligence is that the A-star algorithm. Learning outcome. After completion of this session, students can learn the concept of heuristic search and they can develop analytic skills to evaluate the efficiency and effectiveness of the A-star algorithm compared to the other search algorithms. So in this whole session we are going to see search techniques, A-star algorithm, working of A-star algorithm, efficiency and performance of the A-star, working of this A-star algorithm, how it works actually, which steps are involved here. That is the first, that is the initialization is there. Again the initialization, we are starting from initial state and set the g value. Okay, we know that on there is a one function on which this A-star algorithm works, that is f of n is equal to g of n plus that is h of n. We know that this g of n is that is cost to reach from start at particular node. Suppose there is any node, intermediate node is present in that graph. Okay, from start node to that intermediate node, whatever cost or distance, that is called the g value. So calculate and set the heuristic value. Okay, heuristic value is set to each and every node present in that graph. But what is heuristic value? Heuristic value is that the from that particular intermediate node or any node to the goal node, that actually the direct diagonal distance, or we can say direct distance from straight line distance from that particular nth node to the goal node, straight line distance using some Euclidean distance. So that is called the heuristic value. So using that heuristic value and g value, we are calculating the evaluation total cost from source to destination. So here we are initializing g value and h value for every node. Open and close list. Here we are maintaining two lists. First is the open list and second is the closed list. Initially add the initial state to the open list. Initial state means what? That is first source node we are adding in the open list. Next, here we have maintained this list. Initially just we have added that initial list into that open list. Next, further we are exploring that initial list. We are exploring that initial node means what? Whatever that opened node, we are further reaching to its successors, or we can say its neighbors. Whatever its neighbor nodes, we are visiting to those and we are finding what is f value for each neighbor of that initial value. And after that again further we are exploring whatever node we are getting here. Expansion. Here for expansion what we are doing, that each neighbor of the current node, if neighbor is closed list. Okay, suppose further for further exploration for any particular node, suppose consider there are three neighbor node for that node. Suppose out of these any one node is already closed, means already that node is explored. In that case that is kept and just we are exploring remaining successors of that. So first of all we are calculating g value for that successor. After that we are calculating h value. Here we can see in the formula what is f of n, that is the estimated cost of the cheapest solution, and g of n is that the cost to reach node n from the start state, and h of n is the cost to reach from node n to the goal node. So from source to n, that is g of n, and from n to goal state, that is h of n. So actual total from source to n and n to goal, so it is total, that is called the estimated cost from source to destination or goal state, and which is very most cheapest in that solution space. So add it to open list. After exploring that particular node, after visiting all its children node, we are adding that node into the closed list. At the termination, when we will stop exploration, that if the goal state is reached, reconstruct the path from goal state to initial state using parent pointer. Okay, after suppose at any step we got a goal state, in that case we are stopping here and further we are backtracking by parent until we reach to the initial node, and that will our path. The algorithm terminate with the optimal path found. Whatever the distance from that we have got there, h value plus g value is equal to, that is f of n. That f of n will be the final our optimal path estimated cost or the distance. So here we are going to see one example here. So here we can see here one graph I have taken here. In this graph you can see there is a number of nodes are there. We are considering here as a as a initial state and J is a goal state, and on the node whatever the numbers written, that is the distance, and at particular node whatever value is written there near to that node is that the heuristic value for that node. So initially what we are doing, just we are starting from initial node A and we are exploring its children nodes. We can see there is B and F are its child nodes. So we are calculating that f of B and f of F for that node A. So here f of B is that we know that the f of B is equal to g of B and plus h of B. We know that A to B, what is the distance, that is 6, and what is f of H? H of B, that is 8. So we'll get the f of B is 14 and f of F is 9. So we are comparing, and which is minimum, that is decided as a next node we are going to explore. So its value is now A to F. So further node we have selected for further exploration is that F. So further we are going to explore this F node. There are two neighbors G and F, and as per calculation we will get that f of G is equal to, what is G of G? G of G is that A to B, A to F and F to G. So A to F is 3 and F to G is 1. So we will get 4 plus 5, that is 9. So we can see 9 and 13, 9 is minimum. So the node G is selected for the further exploration. So further we are exploring node G. So as there is a single neighbor to this G, just we have calculated its F value, and further we are exploring that I node. So actually what is my question here is that what is the heuristic value? So what is heuristic value? So we know that heuristic value is the straight line distance from any particular node to the goal state. Further, so what is the heuristic value of the J? As that we know that the J is a goal state. So here J is as a goal state. So the distance from that particular node to the goal state, that is heuristic value of J is 0, because that from same node to same node, okay, from J to J the distance is 0. As we know that the G of A, G of initial state is that from same state to same state distance is 0. G of A is 0 and that H of J is 0. So further at the next step, as we know that I we are exploring, there are total 3 neighbors of this I, and corresponding its function evaluation is there. G we are calculated for f of E calculation. G of E is from A to F plus F to G plus G to I plus I to E. So 1 plus 1 plus 3 plus 5, we can see there is, we'll get plus this h value, that is heuristic value of the E, we will get 15. Next further we are exploring that f of h is 12 and f of j is 10. So after comparison we'll get that f of j is minimum. So for further exploration the j node is selected. So we know that, okay, just we are compared that, but after comparison we got find that j is our goal state, so we have stopped here. We know that in the algorithm, until we will get the goal state, we are going to iteratively exploring the particular node, comparing its heuristic value, and just we are exploring that. So finally we got the path that a to f, f to g, g to I to j, and its cost is 10 as we calculated in previously, that f of j is 10, so j is our optimal cost. So it is very efficient. A star is why it is efficient, because it is using knowledge, it is minimizing its search space at every step, it is complete because there is guarantee that we will get the optimal solution that is close to the best solution. It is very efficient, it is giving us a efficient path. After that it uses the heuristic information, it is an informed search, and it adapts the problem structure, it have knowledge, domain knowledge, and memory also, it also use less memory while working. So these are the references of this session. Thank you.